describe to me, you're both life sciences students here at the UTC, an example of the most mind-blowing moment you had in a lesson in your school.
I'll go first. Well, again, it's not a lesson. It's the work with Dr. Dave Hornby here. It's not based around a set of rules. It's more based around being creative in the innovation labs. I mean, it's called the innovation labs for a reason. So much to do with extracting, DNA, extracting this and that, and just creating our own next project, which we can either just proceed on and find out different information about what could possibly be.
So I've done two key sort of really mind-blowing things. First of all, Professor Dave Hornby assisted us with the incision with recombinant GFP in E. coli. So what that essentially is you get a fluorescent glow-in-the-dark gene and you put it in bacteria, and we learn how to multiply it and grow it and then culture it and then extract this glow-in-the-dark thing. And this sort of technique is used for things like the growth of insulin. So it's all practical, and when I go into a field of science, this is what I'll be doing. Also, in my free time, in my enrichment, I managed to devise my own home test for chlamydia. Not something you can bring up over a meal, I know, but these opportunities are there for us to be creative.
Fantastic. Well, brilliant. I think we should get Dave Hornby on, don't you? I've heard a lot about this guy. Ladies and gentlemen, can I have a round of applause for Professor Hornby, please?
Oops, sorry.
Okay, I'll use the microphone. I'm going to start the presentation in about 10 seconds or so. I've been listening to what Sir Ken Robinson said. Don't agree with everything he said, but that's good. That's about the debate in education. What I've decided to focus on is the importance of communication in science, and actually that communication through understanding or appreciating art is the way that I'm going to approach this. And the first slide here, you'll all be familiar with the chap down at the bottom. That's Einstein, and you'll all perhaps be familiar with the representation of Einstein, which is very much Andy Warhol. And Andy Warhol, for me, challenges the everyday and makes you look at things in a different way. And so what I'm going to try and weave throughout this presentation, probably badly, because anyone who knows me knows that I can't possibly talk for less than an hour when given a microphone or opportunity, so I'll do my best. Okay, so concepts. Science, unfortunately, involves some challenging concepts. This is one that you'll have all heard of all seen, E equals mc squared. It's Einstein's revelation that he could capture an equation, in a simple equation, it's a very simple equation, the relationship between energy, mass, and the speed of light. A little earlier, Darwin and Lamarck were contesting the ideas of through our genes, how do animals, organisms, evolve? And actually, when Sir Ken Robinson talked about acquisition of language, that's the process of natural selection in humans. Nothing complex about it. This is a picture Niels Bohr largely created of the electron with a proton, a nucleus at the center. And I'm going to talk about colour, because colour is all about that little electron there moving up and down an energy level. Art is all about use of colour. This is a photograph, and I include photography in art. This is a photograph of a rainbow. You can see your eye is drawn immediately to the rainbow. It's the breakdown of visible light, which is a mixture of colours. If we see it in black and white, we don't appreciate the significance of the colours, but I think that's still a piece of attractive art. It's a good photograph. It captures the fact that there's some spectacular event going on in the sky. So observation tells you that something's going on, but the colour actually reveals things. I think this is a Matisse. This would be the way in which Matisse manipulates colour in an unexpected way. The rainbow's still up there at the top, but actually you don't really get the rainbow because he's put all these rather garish colours on the houses, the roads, etc. And so you're starting to look at things in ways that perhaps you didn't do normally. This is a much more representational piece of art in which the rainbow highlights down there the iceberg. If you're an artist, you know that you try and put something light in the middle to draw the eye in, and then you start looking round the picture. This is a very good piece of art in that simple respect. And then this is a piece of abstract art. The colours of the rainbow are arranged in different geometric forms in a completely different way. What's the point of all this? Art makes us think about things a little bit differently than the norm. And I really think that this is a key part in creativity and science. Isaac Newton, many, many years ago, perhaps 500 years or more ago, recognised that light is made up of the colours of the spectrum. This is a great experiment that the kids did yesterday in the innovation labs, the primary school kids who were visiting, splitting light up into colours. Now, where do those colours come from? What's the explanation? What's the application? I'm obsessed, as the kids will tell you, about dyes and colour. These are different solutions of organic molecules, a little bit like the molecules you take when you've got a pain. Okay, so they're mixtures of molecules that all have electrons that whiz around in different ways and take some of the light, the white light, out and leave behind a colour. This is what plants do. Plants do this to attract insects. So Darwin told us that the plant will develop the ability to pass out, or if you like, exhibit colour to get an advantage, to get more insects to pollinate. Equally, insects like this put their colours on the back, they go out to the nightclub, they put lots of gaudy colours on, lots of bling, to attract a mate. So colours are there to attract something that allows you to spread your sort of species. It allows you to communicate. So one of my tribe, we heard the word tribe mentioned before, I recognise those colours from a distance while you're sitting on a branch. I'll go over and have a chat. Colour is something that's been harnessed by biology in order to gain some kind of advantage. Here's a fish, it's bright orange. Why would the fish be bright orange? Again, to identify itself, to make itself attractive, possibly to camouflage itself against different backgrounds, harnessing colour for some kind of biological advantage. So in art, where we actually see the use of colour dramatically to persuade us to look at things in a different way, I want to encourage kids to get creative with science and think about using colours. I use colours all the time. Wherever I can use colours, I try to use it to illustrate things. This is a lovely example of using plasticine colours to illustrate the lower intestines, etc. This is also something that I think is important because engagement in the labs. It's critical that the minute they come in, they engage with the process. And you can see here, an artist is in the zone, concentrated on perspective, shape, colour, use of colour, and the kids are actively doing something experimentally, and they become engaged. Chloe before mentioned making green fluorescent protein. On the right there are some tubes from the lab. If anyone wants to, they can read about everything we do on my blog, which comes out basically about once a fortnight. Jackson Pollock on the left here created something that's a mess. Can you see something in it? It takes a while to do that. Okay, it's rewarding. Holly on the right there has been rewarded for doing the best visual presentation of her work. And on the left here, everyone will know that Tracy Emin was rewarded for this. So art gives rewards personally. You get prizes. And finally, I want to, because this is going so quick here, finally, creativity. On the right is the creativity of the kids in the lab using our 3D printer, devices that we use in the lab. On the left-hand side here we have creativity from Picasso. And you look at it and you start thinking, what's in there? Looking a bit harder. So the message for me is that art is an ultimate form of communication because it makes you look at the piece of work, think about emotions, think about difficult concepts. The artist has to try really hard to do that. So if we can get the kids thinking and working like artists and being creative, I think we'll turn them into much more fully rounded scientists in the end, which is only great news for this country.
Everybody, thank you very much. Professor Dave Hornby, fantastic.
Sometimes the schools that we have are still implementing a model of education which doesn't exist anymore.
STEAMco that put together this event is doing fantastic work. It's putting the A back in, which is for the arts.
What I want to see for the children in my class and my own kids is that they have an exploratory nature.
Powering Art Meets Science events in UK schools, we give them a day of creative thinking and doing activities across the STEAM skills.
So our work is looking for ways to break through those inequalities and close the creativity gap.
Within everything around us is embedded hundreds of ideas waiting to be found. We've just got to look closer.
What changed my life was somebody like me being an artist.
It was really, really interesting, and I think the children felt really quite inspired by it.
Because the people who are crazy enough to think they can change the world are the ones who do.